So we are now at a stage where we know how to use this. We know how to use this. If you want to find out this area here, all you have to do is follow this. We know how to use this, but we just don't understand why this thing here works. In order for us to fully understand why this thing here works, we need to understand lots of small bits, and then by understanding those lots of small bits, we can put them all together, and then in the future, hopefully, we will understand why this truly works. Okay, so several videos earlier, we got to this stage here where we know that there exists a C somewhere in between A and B, where this thing equals the average value of f, equals the average value of f. We've established this in several of the earlier videos. The point here is that in the future we are going to so this here is h. Okay, in the future we are going to take the limit as h tends to 0, meaning that we are going to decrease h. So h, hang on, we are going to decrease h. So we are going to eventually decrease h. So remember, h is this here. From here is this gap here. This here is h. Later on in the future, we are going to decrease h. We are going to take the limit as h tends to 0, meaning we are going to decrease h here. But then this c here is always trapped somewhere in between a and b. So this c here is going to be somewhere in between a and b. But as we decrease h, meaning we are moving the b closer and closer towards a. As we decrease h, the c is always trapped in between a and b. It's always somewhere in between a and b. Now it doesn't matter if you don't fully understand this, but in the future we're going to do this. Hang on. So we are going to decrease h. So we are getting b to move closer and closer towards a. But as we're doing that, c is always trapped in between a and b. It's always trapped in between there. But the thing is, as you decrease h, as you decrease h, the c is always trapped in between the two. So as you decrease, forgive my poor animation here. As you decrease h here, c is always trapped in between the two. Okay, it's still being trapped in between. And if you decrease h even further, then eventually, well, don't forget, c is always trapped in between the two. But the thing is, as you decrease h, this f of c here will eventually tend towards f of x. So it will, as you decrease h, f of c, whatever the c is always trapped in between a and b. This thing here will eventually become f of x. Now it doesn't matter if you don't fully understand this, but the point here is that in the future we are hang on, let me put this back. It doesn't matter if you don't fully understand this, but the point is that c is always trapped in somewhere in between a and b. In the future we are going to decrease h. In the future we're going to decrease h, but because c is always trapped in between a and b, eventually we are going to force f of c to become f of x, because as you decrease h, because c is always trapped in between a and b, eventually you're going to force f of c. You're going to force f of c to become f of x. Now it doesn't matter if you don't fully understand this. The point here is that in the future we're going to decrease h here. We're going to move this about, and and the C, just bear in mind that the C is going to be trapped, always trapped in between the two. Okay, it doesn't matter if you don't fully understand this, but just realize that in the future we're going to decrease H and then force that f of C to head towards some sort of limit. Okay.